Hey, Matt Mathersum here with Matt Mathersum. Thank you so much for joining us and being a part of the program today. We appreciate it. We really do. Well, let's see what we are dealing with today. And it looks like for today's topic of discussion is an integration. It looks like it's also a boundless, or as we would say, a indefinite integration. But hark, what is this that I see over here? This is telling me that A is a set of all real numbers, but I'm integrating with respect to the dx here. So what am I solving for? Well, that's a great question. Actually, this A that we're looking at here in the front of the x is a parameter. How do we deal with parameters? Well, stick around and find out because we're going to solve that together and we'll get started and you'll see how we handle parameters. Well, you know with me, there's going to be a formula to handle all this mess, but it's not up here yet. So let me just go ahead and get our formula. And our formula for this is, and we've done this before, haven't we? So it's just an integration of, we've got x to the n dx is equal to x n plus 1 over n plus 1. All right. Well, we've done this before. We know that that formula will definitely get us through this safely and soundly, we hope. Okay. Well, since we've got our formula, let's just start with our very first term. We're working with the x here, and we know we've got the x over here. And the 4 in our case is what's represented over here by the n. Well, what's happening with the n? Well, 1 is being added to it. So why don't we just go ahead and add a 1 to our n over here, and that is going to give us a new value of x to the 5. I'm going to go ahead and write our vernaculum here, our dividing sign. And now we're going to deal with that parameter that we talked about in the introduction, this pesky a right here. Well, we said it is a parameter. How do we deal with parameters? We just treat it like any other number, fortunately. So we just bring this whole 8a thing down, and 8a is now our numerator. All right. What is our new denominator? Well, it's our new exponent is our new denominator. So let's just go ahead and put that sucker down here. Looks like we are done and ready to move on to the 17x raised to the third power. Well, okay, let's go ahead and handle the 1 over 7x to the third power. How do we deal with that? Well, the same way we dealt with this just a minute ago, right? There's no a in here, so we're great on that. All right, well, let's look at our formula, and we've got our x here. We know that 3 is the n over here. We can see again that 1 is being added to the n, so 1 needs to be added to our 3, and that's just going to give us a new value of x to the 4. I'll write our dividing sign over here. And what is our denominator? Where our new denominator is 4, isn't it? Because our new exponent is 4. Well, what about this numerator? What am I going to do with that sucker? Well, the numerator is 1/7, isn't it? It most definitely is. Sorry to say, for those of you who hate working with fractions, but what does this give us now? That kind of looks like a 7, doesn't it? Let me straighten that out because it is definitely not a 7. It is 1 over 7. I want to be very clear about that. Okay, 1 over 7. Well, we've got a complex situation going on, don't we? Complex fraction, because we've got a fraction inside another fraction, but it's going to get even more complexy. I think that's a word. And if not, well, I just dubbed it. So here goes. We all know that 4 is implied over a 1. I mean, any number is implied over a 1. So now we really have a complex fraction, don't we? Okay, we're going to come back to that because you know we've got to do something with that. Well, we're doing all this with respect to our dx. And we know since we don't have a constant, or we have no bounds over here, we have to add the constant of integration to account for all potential vertical shifts, don't we? We do, trust me. Okay, well, again, this is pretty much the answer. We know we're going to have to do some simplification, so let's just go ahead and start the simplifying process. Let me flip around over here, might be better. Let's look at this 8a over 5x to the 5th. Well, you can just tell by looking at that, that is definitely not friendly. There's no simplification that can be done. I don't think dynamite will even take care of that, but I might give that a shot later off camera. Okay, moving on over here to this complex fraction that we talked about. How do we deal with complex fractions? Well, the same way we deal with normal fractions, right? We just multiply by the by the inverse. What is the inverse in this particular if we can say situation, yes, this particular situation. All right, well, the inverse is just going to be 1 over 4. So that is essentially just 1 over 7 times 1 over 4. I'm going to get out of the way here in just a second so you can see that there's no magic here, just basic multiplication. 1 over 7 times 1 over 4 equals 1 over 28. So let me just go ahead and plug that in here right now. Okay, Well, let me just go ahead and bring down this x to the fourth while I'm at it. And I've got the plus c. I cannot forget about the constant of integration. And now that's all that's left is just for me to bring this down as well. And that is the 8a over 5 x to the fifth. Well, that is the answer to this. And actually what we can do, if we so desire, is we can put the c in here and say that the constant of integration as well as the parameters are all real numbers. Woo! Okay. Well, thank you so much for being here with me today. I'm Matt Mathersum. I will see you soon.